scientists discover the angel particle, which is both matter and antimatter at the same time. Researchers have found evidence of a peculiar particle that, ironically, is also its own antiparticle. It was first proposed 80 years ago, but it now seems like it might actually be true. Researchers from Stanford University and the University of California in California carried out the study that was reported in the journal Science. Ettore Majorana, an Italian scientist who mysteriously vanished in 1938, proposed the idea that a particle could have its own antiparticle in 1937. He believed that some fermion particles, like as protons, electrons, and neutrons, ought to have distinct antiparticles. Majorana particles are the name given to these particles in the future. An antiparticle is a particle having the same mass as a regular particle but the opposite electric or magnetic characteristics. For instance, the positron is the electron's antiparticle. Both are destructive to one another if they come into contact. In this experiment, two thin films of quantum materials were stacked on top of one another in a cold vacuum container, and an electric current was passed through them. The top film was a superconductor, whereas the bottom layer was a magnetic topological insulator. By moving a magnet across the stack, the researchers were able to change the speed of the electrons. This resulted in the appearance of electron pairs and what at certain locations appeared to be Majorana quasi-particles. By deflecting one away, the flow of the individual quasi-particles may always be found. The researchers draw attention to the fact that they couldn't properly identify Majorana particles. Instead of Majorana particles, scientists observed what Stanford physics professor Giorgio Gratta described as basically excitations in a material. Confoundingly, it's uncertain if these particles could actually form spontaneously. They are extremely unlikely to occur in the universe, but who are we to judge? Insert Gratta. They proposed the discovery of a new type of Majorana quasi-particle called chiral fermion, which moves along a one-dimensional path in just one direction. The researchers refer to the Majorana particle data as smoking gun proof. Neutrinos have already been speculated to perhaps be their own antiparticles, while independent research is currently being done to confirm this. Senior author of the study and Stanford professor Xiaocheng Zhan claims, "Our team anticipated precisely where to locate the Majorana fermion and what to look for as its a smoking gun experimental signature." With this discovery, one of the most extensive basic physics searches, which lasted exactly 80 years, has come to an end. Subscribe for more videos like this.